Hello? Tell me, Nana. That one we did, right? So in
Yes,
last,
sir. We were discussing ionization potential.
so ionized enthalpy, in last class we have discussed the definition. We had explained the definition also, and we have seen IP1 and IP2. Now we need to see.
Sir, IP3 also, sir.
In last class we had discussed. Now we want to see this. That is. So now we need to discuss about the generally IP2 is greater than IP1. Why? Okay, for this one, what is the we have seen?
Yes.
Generally, what we can say, antikal dabba. By losing one electron, this is gas. By losing electron, we are going to get M plus. And in this case, what is the energy release? That is, we are saying that IP1. And from M plus, if we are removing one more electron, it will form M dipositive. So in this case, that I energy is known as IP2. And we know always IP2 is always greater than IP1. Okay, so IP2 is always greater than IP1, we can say. Now what we are going to say, so why IP2 is always greater than IP1? Okay, the reason is, anyone tell me?
Sir, IP2 requires more energy to pull two electrons because of the electronic repulsion.
No, positive charge. Okay, after removing one electron, so here the nuclear charge will increase, just now. That means what? Mm, After a removal of one electron, the nuclear charge, after removal of electron, the nuclear charge in unipositive cation unipositive cation increases, so that to remove one more electron from the unipositive ion, more energy required. Therefore, what we can say? Therefore, we can say IP2 is always having greater energy than IP1. Okay, this is what we can say IP2 and IP1, Nana. Right? Next one. Next one, we need to go with what are the factors affecting IP1 and how it is going to changes. Okay.
Sir, unipositive means one positive.
Yes, M plus. M
Okay.
plus.
Only one electron is removed.
Yes.
Okay, sir.
What happened? Where is my cursor? Student, 1 second. Somewhere it's happened.
Sir, once can you go to the previous slide?
1 second, please. Mm. Okay.
1 minute. Sir.
Okay, Nana. Okay. I'll see. Next one is factors affecting IP. Okay, factors affecting IP. So, what are the factors which are going to affect the IP values and how they are going to, that we need to see. First one,
Type of atom, sir.
no, what are the factors which will, for example, first factor is nuclear charge.
Okay, like that, sir.
Mm. General, what we can say, nuclear charge means what? Positive charge increases, no?
Yes.
Uh,
More nuclear charge, more
then
positive.
what will happen? More positive charge, so that more is the attracting, no?
Okay.
More is the attraction power of the nucleus by the towards the valence electron. Then what will happen? IP value will
If
be
I
increases or more? Decreases or increases?
decreases, sir.
Mhm. IP value will be increases, no? Because if it
Oh, okay.
is that final last electron is tightly attracted
Yes,
because of
sir.
the nuclear high force of attraction, then what we can say, to remove that electron, we need more energy, right?
Yes, sir.
That only I'm saying that. Okay, that means what we can say. For example, let me take greater the nuclear charge, greater the nuclear charge.
Sir, what is the nuclear charge, sir?
Nuclear charge is nothing but protons, number of protons. Okay, na?
Yes, sir.
Greater the greater the attraction of nucleus on the valence electron. Valence electron. So that to remove electron, more energy is required. Okay. For example, in which case, what is the IP order? Can you tell me?
Sir, Na plus will be the lowest, sir.
Mm,
It will be increasing like that.
very good. Why? Because Na plus means how many protons will be there? 10 protons. 10 or 11 protons? 10
11, sir.
protons. So 11 protons, 10 electrons, right? And a
Yes.
magnesium is 12 protons, 10
12
electrons. And here aluminum is 13 protons, 10 electrons. So easily 13 proton cases, the nuclear charge will be more. So that easily it cannot lose electron. Okay?
Sir, that
Sir,
means aluminum has greater attraction, sir.
Mm,
sir,
mm.
so can we say from start of the periodic table to the end, IP value keeps increasing?
Yes. Periods it will be like that when it will happen. Okay?
Okay, sir.
Next one.
What is periodicity, sir?
Yes. Next one is atomic size.
So can you move move on the previous slide? Okay, sir.
Next one. Next one, what we can say? Atomic size. Tell me. Tell me, students.
What, sir?
Atomic size and IP. How it will
Sir, if atomic size is more, IP will be more.
more?
Less, sir, because attraction will be less.
Yes. Mm, mm. Next one. Okay. So, with increase in atomic size, with increase in atomic size, nucleus attraction on the valence electron increases or decreases?
Decreases, sir.
Decreases. So that IP values
Decrease.
will decrease. Very good. That means size and atomic size inversely proportional. Can I say like that?
Yes, sir.
Mm. Next. Atomic next parameter is nuclear charge, atomic size, penetrating power. Penetrating power means generally penetrating means rushing actually, rushing into. So which is nearby. Generally for any shell, the penetrating power of electrons, sorry, the penetrating power of orbitals are S greater than P greater than T greater than F. That means what we can say. So S orbital are very nearer to the nucleus, we can say.
Yes, sir.
Because they are very small, sir.
Okay, na?
Yes, sir. According to order also that only, no, sir.
That means what we can say. Uh, to remove electron from S orbital,
It requires more IP.
More,
yes,
sir.
from S orbital, very good. S orbital, IP value will be more. Will be more. Done.
Sir,
Tell Chapna. Tell me.
sir, in photoelectric effect IP will be needed or it's natural, sir?
Photoelectric effect, na?
Yes, sir.
Here, there also we are removing electron only, no?
Yes, sir.
So that means what? That is also IP only. Okay.
But the
But actually,
terms
what
are
will happen?
different,
See,
sir.
to remove that IP, just we are giving energy in the form
Reactive
of
metal.
light.
Yes, sir.
That's why. Okay, na?
Yes, sir. Thank you.
Next one, penetrating power we have done. Next one, next parameter, half filled or completely filled orbitals. Okay, half filled or completely filled orbitals. That means what we can say is here. Half filled means no, like this.
Yes, sir. Only one direction.
This is P3. In case of
Sir, P will have three subshells, sir.
D, sir. Next one.
this is in case of d orbitals. Okay. Now, uh, mm, next one, see. Uh, see.
Sir, these boxes are subshells or orbitals?
These are the d orbital, right? So individual box indicates the subshell.
A single box is subshell.
Yes.
Okay, sir.
Next one, see. So completely filled and half filled orbitals has greater stability. So if the atom is having greater stability means what we can say, so that IP value will be more. Okay. Next. So next parameter is screening or shielding effect.
Sir, this is a new topic or part of IP, sir?
Part of IP only. Factors only I am discussing.
Oh, okay.
This is the last factor. Screening effect or screening effect means what we can say. See, generally screening effect means what we can say. See, uh, screening means which protect, shield means which protects actually. Okay, na? Uh, Shielding effect means shielding effect means with increase in number of electrons in inner shells, with increase in electrons in with increased number of electrons in inner shell, the force of attraction on the valence shell
Sir, once can you go to the previous?
Decreases, sir.
decreases. Okay.
So IP decrease.
Okay. So this is what we can say about the shielding effect. Okay. First write down. Done.
1 minute. Done, sir.
Next one. What we can say generally. Uh, with increase in shielding effect, with increase in shielding effect, what we can takes place? IP values will decreases. Okay, na? Generally, shielding effect order is that means what we can say D and F orbitals will have poor shielding effect. Okay,
Sir, so S will have low IP, sir.
S will have lowest IP.
Sir, but before only.
No, lowest IP. Na. S value will have highest IP. Na?
Okay, sir. Shielding effect is highest in F, sir.
Ah,
Okay.
okay. That means what we can say. I think I have written ulta order. I think right. Shielding effect I have written. No.
Yes, sir. F should be highest, sir.
That means okay. Let me write like this.
Sir, what are inner shells, sir?
Inner cells means what? For example, always we are going to take electrons from the last cell, right?
Valency cell, sir.
Valency shell, that is lost shell, no? So
Yes,
before
sir.
valency, that all cells are comes under inner cells only.
Before valency, sir.
Yes.
Okay, sir.
Then next tell me, Nana. Next point is uh, so how this is going to change in periods and groups. Okay, trends in how IP values changes in periods and in groups, how it will take place. Mm, what we can say, uh, generally,
Sir,
mm,
sir, general shielding effect order is SPDF or FDPS, sir.
so generally what we can say, the electrons which we are going to uh, fill in d orbital or f orbital, Anna, generally. Okay, actually whenever the question will come, at that time I will tell you, that's why I haven't written here, right?
Okay.
Generally what we can say, whenever we are having, when generally if s if d and f orbitals we are filling the electrons. Okay. Hello?
Okay, sir.
So if we are filling, no, so that will be what we can say, these are poor shielding effect, actually it will be there. That means even if you are filling electrons in p and d and f orbitals, no, it cannot be shielded that much of properly. That means in case of d and f orbitals, even though you are filling electrons in f orbital, the valence electron is tightly attracted by the nucleus, so that in such case cannot be removed electron easily. Okay, that's why I haven't written here. Okay, you will study in next year if you are going for higher classes, again you will study in detail. Okay, generally in groups,
Which one, sir?
this one only, Nana.
Okay, sir. IP increases, no, sir.
Only with increase in size, IP values will become decreases, no?
Yes.
Whereas in periods, how it will be changes,
Sir, but in groups, protons will be increasing, no, sir.
but size increases a lot, no? Because
Okay.
number of cells increases.
Yes.
Uh, Okay. Next one,
Sir,
in periods, generally from left to right in a period, what will happen? Size increases or decreases?
Increase.
Decreases, no?
sir,
So
actually, I
IP
didn't
values,
understand the topic, sir.
which one?
From the increase or decrease of atomic size and IP.
Are yeah, simple, yeah. As we have seen, no, atomic size increase. How size and IP values will be directly related or indirectly related? Tell me.
Direct,
It,
sir.
are, what you are listening, Nana? What we have written here, say, with increase in atomic size, nuclear electron increase, so that IP values will decrease, yes, no? That is
Yes, sir,
inversely
inverse, sir.
proportional, I said, no?
They're inverse, sir.
Uh, Inverse, right?
Yes, sir.
Now say in group size will increases or decreases?
Size
Tell
will
me.
sir,
Size will?
increase.
If size is increases, then IP value will decrease or increase?
Decrease, sir.
That one I have written. No? In period, size will increase or decrease?
Increase, sir.
Size
Decrease, sir.
decreases. Then what we can say? IP value?
Decreases. Increases, sir.
Done. That's only, no?
Yes, sir.
Next one. This is generally trend. So if I'm taking, but if you're taking second period, no, so there are certain exceptions are there. Okay. Generally periods it will take place like that, but certain exceptions are there if you're taking second period. For example, what are the second period elements? Tell me. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and no doubt neon inert gases is there. To remove electrons from inert gases, it will need highest energy. Let me write configuration. What is lithium configuration? 1s2, 2s1, and in case of beryllium, 1s2, 2s2, and in case of boron, 1s2, 2s2, 2p1. In case of carbon, 1s2, 2s2, 2p2. Nitrogen, 1s2, 2s2, 2p3. This will have 1s2, 2s2, 2p4, and this is 1s2, 2s2, 2p5, 2p5, and this is 1s2, 2s2, 2p6. Now tell me, size from lithium to beryllium, IP value increases or not? This is IP order I'm writing. Tell me, lithium to beryllium
Decreases, sir.
size will
Yes,
be
sir.
decreases, IP value will be increases. Okay, na? Whereas coming to beryllium to boron, size increasing, no? So IP value will also, size decreasing, no? So IP value will also, you are not responding. So these are all period elements, isn't it?
Yes, sir.
Uh, from in periods left to right, IP value should increase or decrease? In periods from left to right, IP value should increase or decrease?
Increase.
Decrease.
IP
IP
increase.
value, IP increases. So from lithium to beryllium, it is increasing, no doubt. Any doubt?
No.
From beryllium to boron also, IP value should increase. But here what will happen? IP value will decreases. Why? So here we are having exception in this case. Similarly, in case of boron to carbon, again it will increases. Okay. From carbon to nitrogen also increases, no doubt. When it's coming into nitrogen to oxygen, again instead of increasing it will decreases. So here we have again exception. Whereas from oxygen to fluorine, obviously it will increases, and fluorine to neon also it will increases more. Now question is, in case of beryllium to boron, IP order is this, right? In case of beryllium is greater than boron, IP values. Why? Tell me. Tell me one of the parameter which we have discussed, na? Factors affecting we have discussed, no? One of the factors. So what is the factor? You need to tell me.
Sir, in beryllium, IP value is greater because the beryllium size is less than boron, sir.
Oi, boron size is less, no?
So boron size is less means boron IP should be more, na, sir.
That one I said, no? From left to right, beryllium to boron size should be greater. Size is decreasing. So IP value should increase. But instead of that, we have written beryllium is high. Why?
Sir, orbital is adding, sir. p orbital.
Yes, very good. So in case of beryllium, from where we need to remove electron?
S orbital, sir.
Yes.
Whereas in boron,
P. S is
we
P.
more
see,
IPs.
cell is same, no? See, now what we can say, penetrating power, what we can say?
S has more.
Yes, so penetrating power of s orbital is greater than p, right?
Sir, half-filled configuration.
Where half field corruptus in boron we got? So that IP values will be more in case of boron. Sorry, in case of beryllium as compared to boron. Half field in case of P and D only it will be there, no? PDF only, no? Second, from nitrogen to oxygen, mm, from nitrogen to oxygen, IP value is decreasing. But actually what it's supposed increases, no? Why? For this one, what is the reason?
Half fill.
Very good. We have where we have half field in nitrogen or oxygen? In nitrogen,
Nitrogen.
half filled electronic configuration is there. Half filled electronic configuration is there. So as it is more stable, stable molecule, stable atom. So from the stable atom, what we can say, IP value will to remove electron from its stable atom. So IP value will be more, no? Okay. Mm. Understood? What did I say? Okay, now students.
Yes, sir.
This is about the uh, next point. Nana. So let's go with we have time now, so we will go with one more definition, that is electron gain enthalpy. Generally we call it as this only electron affinity, but we have difference is there, slight difference is there in terms of values. Mm. Electron gain enthalpy can be defined as defined as the amount of energy released the amount of energy released when when an electron is added to neutral gaseous atom neutral gaseous state of atom to form negative ion. So what we are saying there here, so IP value means energy we are providing to remove electron, isn't it? And here what we are doing, we are what we are doing here, we are adding electrons. So when we are adding, no, energy is getting released. So energy released means it is a negative exothermic or endothermic.
Endo, sir.
Endo energy released means endothermic.
No, exo.
Exo.
Exothermic, no.
Yes.
So it is generally, it is exothermic.
Sir,
Certain exceptions also there.
it is important, sir.
Which one, Anna?
For this, it should be isolated, sir, or no need, sir.
Isolated only. Any atom should be isolated only. Ground state of atom, neutral atom only required.
Okay, sir.
For example, let so this is I'm taking as an X is an element I'm taking. Okay. When we are adding to electron to this, so what it will form? It will form X minus, isn't it? So in this process, whatever the energy we are saying that no energy release, no, that we are saying that electron gain enthalpy, that is delta Eg. Eg means electron gain enthalpy. This indicates electron gain enthalpy. Okay. Understood what I'm trying to say?
Yes, sir.
So this is, if I'm taking this first one, and if I'm taking one more electron, this is what we can say. Electron gain enthalpy 1 we can say. Here another released is electron gain enthalpy 1. X minus, if we are adding one more electron, no, so it will form X minus 2. So in this process, whatever energy we are using, so this will be electron gain enthalpy 2. Okay. Eg means electron gain enthalpy. Otherwise, we can say electron affinity 1 or electron affinity 2. That is EA1 or EA2. Okay. So for this, we will discuss little bit more in coming classes. Okay, na? Okay, na, students?
Yes, sir.
Yes, sir. Thank you.
Okay, students, then. Bye. Good night.
Thank you, sir.
Thank you,
Good
sir.
night.
Bye, sir.
Thank you. Bye, sir. Good night, sir.
Sir, sir, sir.